Now suppose we go ahead with this anionic form. Then there will be other aldehyde left unreacted. And this is the anionic form of this carbon. I have just rearranged it and have wrote it in a different configuration. This is same as this. So this will approach another aldehyde unreacted, and this acts as a nucleophile. So this C- will attack this C double bond O, as Grignard reagent attacked C double bond O, as Gilman's reagent attacked C double bond O, as dialkyl cadmium attacked C double bond O. So this is a general nucleophilic attack of R-. So consider it as R-, and this is attacking this C double bond O. When it attacks this C double bond O, a bond of this carbon has to be broken, and the electron of that bond has to be shifted into the orbital of oxygen like this. And this becomes C+, and this is C-. So there will be a bond formation between this carbon and this carbon like this. That's it. Now when you add H+ from outside, then these two O- will be neutralized, and you will have OH and OH. So when you add H+, H2O, then you get Pinacole. Like this. Now if you took this, now there will be, if two molecules of this free radical form of intermediate will dimerize, the C dot and another C dot will dimerize to give you the same product. So if two of the molecule dimerizes, this C dot and another C dot will form a bond, and you will get the same intermediate. So you will get the same Pinacole. Fine. So you can take any of them. So you have now Pinacole. Now this vicinal diol is Pinacole. Once you have Pinacole, reaction will not stop at this stage, because you have added H+ H2O. Now those H+ will go into to any one of the OH. In this case, this is a symmetrical Pinacole. So you can carry on the reaction further, adding H+ to any one of the OH. H+ being deficient of electron will go and form a bond with some electron-rich species. And that electron-rich species here is oxygen. Right? So OH will turn into OH2+, because oxygen gives its electron to H+, so oxygen will generate this plus charge. Now water is a good living group. How many times we have discussed that? Water is a stable solvent. Water is thermodynamically very stable, so water is a good living group. It will leave and go away and have a stable independent existence. When it does that, it has to go out as a neutral molecule. At present, oxygen has plus charge, so it will take away the electron of the carbon in order to neutralize itself. When it does that, this carbon will generate a plus charge. So what happens is, an intermediate like this is produced. Now let's look at the situation here very carefully and try to fit that like a photograph into your brain. Whenever this kind of situation is generated, only one thing will happen, and that will be always and always be the next step from here. Whenever you have a plus charge on the carbon, whenever you have a plus charge on a carbon adjacent to the carbon having OH group, that means if OH group is attached to that carbon, then the beta carbon, this carbon will be a alpha carbon for this OH group, and the carbon next to this alpha carbon will be beta carbon. So whenever you have a plus charge on beta carbon with respect to OH group, then a group attached to the alpha carbon will migrate to beta carbon in order to bring a plus charge on alpha carbon. Let's see why, but let's migrate a group and bring the plus charge from beta carbon to alpha carbon. Now for migration, a plus charge can be brought by migrating either of the two groups. Now this carbon has one hydrogen like this and one methyl like this. So any two of them can migrate. Now earlier we have seen, when we studied hydride shift right in the beginning of starting the reaction mechanism, we have studied a concept like hydride shift, or shift of a group in general. And there we saw that the migration aptitude of hydrogen is the highest among all the groups. So here, because of hydrogen, this hydrogen will migrate and not of methyl. The reason they give for this is the small size of hydrogen, so that they can penetrate into the solvent molecule and reach to the carbon very easily. So the migratory aptitude or the migration aptitude of this hydrogen is highest among all the groups. So this hydrogen will migrate in the form of hydride H minus from this carbon to this carbon. It will be a slow process, but for the sake of convenience, we can do it like this. We can break this bond, produce this H minus. When this H minus is produced, a C plus will be generated here, and this H minus is going to form a bond with this C plus. When that happens, you will get something like this. This C will become, already have one hydrogen, another hydrogen comes, that becomes CH2 and then CH3 group. Now see, this is a situation where you can get a very highly stable double bond, C double bond O. Now oxygen is electron rich, it has a lone pair, and this carbon has an empty orbital. This is a completely filled orbital in the form of lone pair. So electron will start to diffuse from this filled orbital into this empty orbital, and a bond will be formed between oxygen and carbon. When that happens, we get this CH3 C double bond O. Oxygen has given its electron, so it will generate a plus charge, CH2 CH3. Now this plus charge can be dispensed when this hydrogen goes away in the form of H plus. When it goes away in the form of H plus, it leaves its electron, and this oxygen becomes neutral. This oxygen becomes neutral. Now you have this ketone as the final product, right? So this is a Pinacole Pinacolone rearrangement. The rearranged form is called Pinacolone. This is Pinacole. So we are rearranging Pinacole to get Pinacolone. Pinacole Pinacolone rearrangement. Finally, we end up in a ketone. So this is a method of preparation of ketone. Fine? Fine. Now this is important. Before I rub this is very important that when you have a situation like this that we had previously, when you have a plus charge at beta position with respect to OH, quickly this C double bond O is generated. Now capture this, how this is generated. First, a plus charge is generated on the carbon which is directly attached with OH group. How does that happen? By migration or shifting of a group. When that plus charge is generated on the carbon directly attached to oxygen, then that oxygen starts giving its electron into the empty orbital of this carbon, and C double bond O is generated. So from here, always you will end up in a C double bond O, right? Nevertheless, this is Pinacole Pinacolone rearrangement. Now a twisted form of the situation that we have been discussing can be given to you. Suppose you have been given a problem like this. They have given AlCl3. Now this has nothing to do with Pinacole Pinacolone rearrangement, but it has everything to do with the concept I have been telling you. Now in this case, what happens, as was the case in Federal-Kraft acylation, Federal-Kraft alkylation, we have seen this situation before, that AlCl3 is a Lewis acid. It pulls up chlorine out of the substrate in the form of Cl minus, right? So this AlCl3 is going to pull out chlorine and form AlCl4 minus. So that chlorine is going to come out as Cl minus. And when that chlorine comes out as Cl minus, a plus charge is going to be produced on that carbon. Now look, this is a kind of situation where the plus charge is on beta carbon with respect to OH. Now what will happen is there's a hydrogen here. This carbon has been shown with 3 valency. The 4th is always satisfied with hydrogen. So that hydrogen will quickly shift to beta carbon so as to facilitate the formation of plus charge on alpha carbon. So 1,2 hydride shift will occur, and you will have a hydrogen at this position, this hydrogen coming on this carbon, plus charge being generated on the alpha carbon, and when this happens, the next step would be this oxygen would give its electron to the carbon and form a double bond. So you will end up in cyclohexanone. So remember, this kind of situation is important. C double bond is the strongest double bond of organic chemistry. It is a strong factor for providing stability. It's a factor that dictates the pathway of the reaction. We didn't go in any other pathway. We followed the pathway that brought about C double bond O. So it dictates the mechanism of a particular reaction. So C double bond O, this is certain factors in organic that we think of. We try to generate aromaticity, we try to generate C double bond O. That helps us to decide in which path we should go. Alright, so this fourth reaction is done.